I will start the session by introducing myself. For those who don't know or the participants from elsewhere outside of UITM, my name is Dr. Yong. I am the lecturer who teaches a subject called Soil Science and Analysis in the Faculty of Applied Science, Universiti Teknologi Amirah, Shah Alam. Now, today I have the privilege of from Miss Amirah Saidin, who used to be my students back in a time of COVID, if not mistaken, even before
No,
COVID.
before that,
Yeah.
2015 until 2018.
Yeah, before COVID, that she was my FYP students, and we have a really fond memory working on a lot of things, the project and also her internship. And I'm pleasantly surprised that she is doing her PhD right now in UMS. So hopefully that she can be like we can be colleagues sooner than later. Yeah, I can't wait because erosion is some subjects that is really close to my heart because of the many disasters that we're having, not only in Sabah and Sarawak, but also in Semenanjung. Erosion is really part and parcel of our daily life due to the overextended development in our country. So without further ado, I would like to invite Miss Amirah to start her presentation. So Amirah, please, the floor is yours.
Assalamualaikum and good morning, everyone. Thank you for joining this session. First of all, I would like to thank you, UITM, especially my SV during bachelor, Dr. Yong, for inviting me to be part of this collaborative teaching program for soil science and analysis. Okay, let me brief a little bit of myself. Yes, I am an alumni of this program, and I was once an environmental science student here at UITM, just like many of you today. And honestly, I never imagined that I will one day return to UITM as a guest lecturer. Thank you so much, Dr. Young, for this opportunity. And it feels very special for me to return to the place where my journey began. And I'm delighted to have the opportunity to share my today session with you guys. So before we begin, let me, when we talk about soil erosion and flooding, most people think of heavy rainfall, right? And yes, that is correct. Rainfall is an important factor, but is the rainfall the only cause of flooding? And what happened when the soil is eroded from hill slope and transported into river? Can soil erosion and sediment increase flood risk? This is all the question that we explore today. Okay, so move forward. Okay, before we begin, this is the learning outcome that we will explore today. So by the end of this session, hopefully we will able to explain how the process of soil erosion occurs, identify the factor that influencing erosion risk, and understand the relationship between erosion, sedimentation, and flooding, and interpret the soil erosion risk map. And lastly, we can discuss the sustainable erosion management strategy. So hopefully, this session will encourage you to think about how soil, water, land use, and human activity are interconnected with environmental system. Okay. I think this has been told, this has been taught by Dr. Yong in previous class, right? So what is soil erosion? So, in simply terms, soil erosion is a process by which soil particles are detached, transported, and eventually deposited in another location by agents such as water, wind, or gravity. But the agent of erosion, basically not only these three, we have few others such as ice. But for our country, we only, I think, this is the main agent of erosion, which is water, wind, and gravity. So, many people think erosion is a simple soil being washed away. However, we as environmental scientists, we need to understand more deep, such as where the soil come from, where it goes, and what happened after it leaves the land surface, and why it's important to we understand this soil erosion, because erosion involve remove valuable topsoil, reduce soil fertility, and increase the amount of sediment entering river and stream. So there are three key process that involved in erosion, such as first is detachment, whereby the soil particles are detached from the ground surface. Then after it detached from its group, it transport into another location by the agent of erosion that I have mentioned just now. Then it when the energy of the transport is lost, they deposited into our river, lakes, and lowland area. Okay, the as you can see from the image that I have included, that is example of riverbank erosion that happened in Kota Blut. That caused by flowing water, where it eroded the riverbank, exposed the plant roots, and the soil is then transported downstream as a sediment. Okay, we have know what is the meaning, what is definition of soil erosion, and what is the process, right? So we will look at the different types of soil erosion. Okay, this is the type of soil erosion. And when we talk about type of soil erosion, the most important thing that we need to remember and clear that the types is not happen at once. It happens over the time. So it's begin with the splash erosion, whereby this is the, as you can see, the splash erosion is the initial stage of erosion, whereby it happened because the raindrop impact the soil surface and detach the soil particle from its group. Then the second, it's become sheet erosion, where the where a thin layer of topsoil is removed by surface runoff. Although this, I think this type of erosion is difficult to identify it is erosion or not. But it's involving removing of the nutrient at the surface of the soil. Then after that, it's become the real erosion, where as runoff become more concentrated, a small channel called rill begins to form, and from the rills, if the erosion continue, it's become the gully erosion, where the channel become more larger and deeper to form the gully, and the gully is the most severe one. So, where to identify between real and gully, real erosion usually less than 30 cm deep, but for gully is more than 30 cm deep, and cannot be removed by normal cultivation lah. So we notice the progression of the erosion from the initial one to the severe one. Just a raindrop impact, and finally it become the gully erosion. So so controlling erosion at an early stage, it is important because it helps reduce sedimentation and minimize future flooding. Okay. We just now talk about the types of erosion. No, we talk about soil erosion. Why is soil erosion? It's important for us to know, to understand, because soil erosion is not just a local issue. It's involved global environmental challenge that faced by all around the world lah. It's contribute to the land degradation, sedimentation, water quality deterioration, and increase the flood risk. Many people assume that soil erosion only affect the land surface. However, the impact extend far beyond the hill slope. Soil erosion contribute to land degradation by removing the valuable topsoil, which is essential for agriculture and ecosystem health. Besides that, eroded soil does not simply disappear. It's transported into river and stream where they accumulate as sediment, and over time, this sediment can reduce river capacity, making river less efficient at carrying water during heavy rainfall event. So at the same time, climate change impact is increasing the frequency of intense rainfall events in many regions. More intense rainfall leads to greater erosion, increase the sedimentation transport, and potentially greater the flood risk. Okay, now we look at why it is matter. As you can see from the slide, it shows the change of environmental impact that begins with soil erosion and finally to the increased flood risk. First, for this process to be happen, the topsoil is detached from the land surface and removed. Since topsoil contains most of nutrient and organic matter needed for plant growth, it reduced soil fertility and agricultural productivity. So bear in mind, soil erosion not just eroded the soil, but it eroded the soil fertility and all nutrient that important for our tanaman lah, untuk kita tanam-tanam pokok, right? That. So the eroded soil is transported by runoff and eventually accumulate in river, reservoir, and drainage system. So this process is known as sedimentation, whereby as sediment accumulate, water quality can deteriorate due to increase of turbidity, and this impact the aquatic habitat in the river or river, lakes, and the place where the sediment occurs. And more importantly, sediment also can reduce the capacity of river channel to carry water. So, when the heavy rainfall occurs, river will reduce its capacity and it's easy to be overflow because the capacity have been reduced, right? Therefore, this reducing capacity will increase the flood risk. Okay. So, what drives soil erosion? In general, soil erosion is influenced by two main factors, such as natural factor and human factor. So, in natural factor, the main issue involve the rainfall, but we cannot I mean, for rainfall, no, we cannot do anything because it is the natural factor, right? So Malaysia has a high intensity rainfall, which this can increase the runoff and increase the erosivity power of water. Second is slope. The steeper the slope, the faster water flow down slope, which increase the potential for soil erosion. And third factor is soil properties. Because different soil types respond differently to rainfall. Some soil are more resistant to erosion, while others are more easily detached and transport. However, natural factors are only parts of the story for soil erosion. Human activity are significantly accelerate erosion process. For example, land clearing expose the soil surface, whereby the removal of vegetation reduce the natural protection that help hold soil particle together. Similarly, the urban development and construction activity increase surface runoff, which can further intensify erosion and sediment transport. So at the end, we understand that nature start the process, but human activity can accelerate the process of erosion. Okay, sorry for the disturbance. Okay, so bear in mind, nature start the process of erosion, but our activity uh, accelerate the process of erosion. Okay, so far we have discussed on rainfall, slope, human activity as a driver of soil erosion. However, erosion also depend on soil characteristic. Because not all soil respond to rainfall in the same way. Some soil are highly vulnerable to erosion, while others are more resistant to erosion. So several soil properties which influence the erosion risk, including the soil texture, soil structure, organic matter, infiltration capacity, soil compaction, and soil cover. So among of these factors, vegetation cover is one of the most important because soil protected by vegetation is less exposed to raindrop impact and surface runoff, where a bare soil is much more vulnerable to erosion. And another important factor that we need to understand is infiltration. So when water infiltrate into the soil, less runoff is generated. However, when infiltration is low, more water flow over the surface and increase the risk of erosion. For soil compaction, it also play a vital role because a compact soil produce pore space, limit infiltration, and increase the runoff. So here we can understand that soil erosion is influenced not only by rainfall, slope, but also by the soil condition. A healthy, well-structured soil with good vegetation cover are generally more resistant to erosion. So we, as environmental scientists, need to understand that these soil properties help us identify areas that are more vulnerable to erosion, and develop appropriate management strategy. Okay, so why Malaysia is particularly vulnerable to soil erosion and flooding? Because the answer lies in combination of several risk factors. First, we are tropical country where we have the high annual rainfall. According to Met Malaysia, Malaysia receive 2,000 until 4,000 millimeter annually. So this is a large amount of water that can generate runoff and detached soil particle. Second, many parts of Malaysia, especially Sabah and Sarawak, have a steep and mountainous terrain. So on steep slope, the water flow more faster. This will increase the potential for soil erosion. And third, Malaysia experience intense monsoon rainfall, particularly during the northeast monsoon. So this high intensity rainfall event can accelerate erosion and sediment transport. And lastly, we have a rapid land use change, including urbanization, agricultural, and infrastructure development, where often expose soil surface and increase erosion risk. So when this factor occurs together, they can create an ideal condition for soil erosion. But my question here, if Malaysia receive a high rainfall every year, why not all the area experience the same level of erosion and flooding? Anyone can answer? No. Sorry. Okay, it's okay lah. Let me answer myself back, because rainfall alone is not enough. We must also consider slope, land use, vegetation cover, and human activity for the erosion to be happen. Okay. So flooding. So what we can identify here, flooding is more just heavy rain. Flooding is not caused only by heavy rainfall, but rainfall is certainly an important trigger, where flooding is often the result of much larger environmental process. As shown in the diagram, natural process, natural factor, and human activity, when combined, it accelerates the flooding event. Once, the basic chronology in the simple one is when soil is detached, it is transported downstream as a sediment. So over time, this sediment accumulate within the river channel. So when the sediment accumulate, it's called a sedimentation process lah. So as a sediment build up, river capacity is reduced. So this means river can hold and transport less water during the rainfall event. As a result, when heavy rainfall occurs, rivers are more likely to overflow and cause flooding. So when now we look at the picture here. This is the image, the case study that happened in Kota Blot during the flooding. I forgot. I think in 2020 or something like that lah. So when we see at this picture, we often focus that because of rainfall it is happen. However, we as environmental scientists need to think more deep. I mean, we should also ask why, what happened before the flood. Was there a land clearing? Was there a soil erosion upstream? Was sediment accumulating in the river? So this factor can strongly influence the severity of flooding. So far we have discussed on cause of soil erosion and why it is important environmental issue. So let we answer the key question of lecture today. How does soil erosion contribute to the flooding? So the process begins with a heavy rainfall. When rainfall fall on the exposed or vulnerable soil surface, soil particles are detached and transported by runoff. This erosion stage. Then the second stage is a sediment, just I told right now, where the soil are being deposited in our lake, reservoir, river, and so on. So by this sedimentation process occur, the river capacity have been decreased. So this from this picture before sediment and after sediment, we can see the differentiation between the capacity, the channel capacity to convey water. So before sedimentation, it's more deep, but after sediment occur, it lower the channel capacity. So which from the before sediment and after sediment, which you guys think that the river will be more easy to flood or for flood to be happen. So let's the student, I think, can ask 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 ourselves lah. So from the after sediment and before sediment, which the overflow can easily to be happen. So the the answer is after sedimentation lah, because before sedimentation, the river channel is deeper and can store more water. But after sedimentation, the channel become more shallow and part of its space has been occupied by the sediment. So this will cause the water, this will cause less water, so this will cause the water, a little bit water can be bring by the channel, so less water can be bring lah. So now we imagine the next heavy, if after sedimentation, now we imagine after sedimentation, it's already full by the water. Then a heavy rainfall comes. Okay. So if the water comes, the rainfall still same, but the capacity to channel low. So this will cause the area around the channel overflow. I mean banjir lah, flood plain, like that. So it increase the likelihood and severity of flooding. So the photograph that I have included, whereby the infrastructure damage in Kota Blut, where the bridge have been runtuh during the banjir, due to no, not banjir, air besar. So this cause runtuhan jambatan in some area in Kota Blut. So as you can see, there are erosion started on the riverbank of sungai. Okay, this is I have told you just now. Whereby we often talk about rainfall, soil erosion, and flooding, but less of us sometimes forget that the sediment is one of the important factor uh, that become the hidden link between soil erosion and flooding. This is why sediment management is important part of flood risk management, because if we only focus on rainfall and ignore sediment accumulation, we may overlook one of the key driver of flooding. So for example, uh, this is what have been faced by the Kota Blut. That's why my study also in Kota Blut, whereby the 2015 Rana earthquake significantly alter the morphology and geological characteristic of river system in Kota Blut, where a strong ground shaking established slope, loose soil, and trigger numerous landslides. Thus, it transporting large volume of sediment into downstream river channel. So over time, this sediment accumulate within the riverbed. So the sungai in Kota Blut after the earthquake become cetek. It's lebar but cetek. It reducing the channel depth and flow capacity. So as a result, during periods of intense rainfall, the river become less efficient at conveying flood water, thereby increasing the frequency and severity flood in Kota Blut. So this is what I just mentioned just now, the case study of Kota Blut, what I have been kaji research for my study. So let's look at real world example from Kota Blut, Sabah. So why I choose Kota Blut as my case study, because Kota Blut is vulnerable to flooding due to several factors. Okay, before that, I know many of you maybe do not know what is Kota Blut, Sabah, and so on like that. Okay, Kota Blut was located at Sabah, and it's around 1.5 hour or 2 hour from Kota Kinabalu. It's just jiran lah. Kota Blut located just not beside lah. It's sempadan with Ranau. Like that lah. So that's why I just mentioned, when the earthquake happened, the Kota Blut have faced the also the impact of earthquake. Okay. So just back to the slide. Okay. Kota Blut is highly vulnerable to flooding due to several factors, because this area has a high rainfall and seasonal because this area receive high annual rainfall and influenced by monsoon season, and it support extensive agricultural activity such as tanam padi, tanam getak, and ada juga sedikit tanam sawit. So with this activity, it expose soil to erosion, and at the same time, there are sediment accumulation in river, which can reduce channel capacity and increase the flood risk. So to study this issue, I combine rainfall, soil characteristic, land use data, satellite image, and DEM to identify the soil erosion in combination with GIS and Russell modeling lah. I think Dr. Yong also in his lecture has mentioned about Russell, right? So Russell is modeling for soil erosion mapping. It is empirical modeling for soil erosion. As you can see, the maps on the right show how these different factors contribute to soil erosion risk across Kota Blut. So when we combine all of these factors, we can identify areas that are more vulnerable to soil loss and require greater conservation and management attention. So in short, Kota Blut provides a good example of how rainfall, land use, soil erosion, and sediment interact to influence the flood risk. Okay, based on the erosion risk map, we can identify the area that are more vulnerable to soil erosion. So the findings suggest that erosion-prone area can become important source of sediment. Because the findings show that the erosion happen on the high slope. The findings show that high slope beside the river channel. So the erosion mostly happen in that area lah. So over time, this when erosion happen, the sediment occurs and accumulate within the river system. So this reducing channel capacity and increase flood risk. So this is why soil erosion is not only a land management issue, but also a flood management issue. So from this finding, there are several important implications. First, erosion risk map can support better land use planning by identify areas that require protection or careful development. Second, understand the erosion hotspot, which can reduce future flood impact through a targeting mitigation measure. However, several challenges remain, including climate change, more intense rainfall event, urban expansion, and ongoing land degradation. So to address this challenge, a range of management strategy can be implemented, including reforestation, contour farming, tracing for the high slope lah. So we can do the reforestation, contour farming, tracing, and sediment control measure, and continuous monitor using GIS technology. So throughout this lecture, we can see that soil erosion, sediment, and flooding are closely connected. But managing one of these issues requires us to understand and manage the other as well. Okay, this is just to think about it lah. So before I conclude today's session, let's test our understanding with a simple question. Can flood occurs even if rainfall remains the same? Let me answer it myself lah to save our time. Yes, if sediment accumulation reduce river capacity. I mean the answer is B. Yes, if sediment accumulation reduce river capacity, because flooding can become more severe even when rainfall remains the same if sediment accumulation reduce the capacity of river to carry water. Throughout this lecture, we have seen how soil erosion produce sediment, how sediment accumulate in river channel, and how this reduce the space available for water. As a result, river can overflow more easily during rainfall event. This is why flood management is not only about uh, managing rainfall and drainage system, but also about managing soil erosion and sedimentation. Okay, as a conclusion, before I end today's session, I would like to leave you with four key takeaway. First, soil erosion is a natural process. However, human activities such as deforestation, poor agriculture practice, and land development can greatly accelerate the erosion process. Second, sediment is the critical thing or critical link between soil erosion and flooding. When eroded soil is transported into river, it's accumulate on the riverbed, reducing the channel capacity to carry water. Third, flooding is not caused solely by rainfall. It's also influenced by sediment accumulation, river capacity, land use, and watershed condition. So this is explained to my question just now. Why if we receive the same amount, why not all area are flooding? Why only certain area is flood? Yeah. So some area experience severe flooding even when neighbor area receive similar rainfall amount. And finally, sustainable land management can reduce both soil loss and flood impact. So, practice such as maintaining vegetation cover, protecting riverbank, proper slope management, and careful land use planning can significantly reduce the soil loss and sediment transport, and ultimately flood risk. So, in the connection section, this is the summarized today discussion, where it's began with the intense rainfall together with human activity, increased soil erosion, then produce sediment, which transported into river, and accumulate in the river, thus decrease decrease the river capacity and increase the likelihood for flooding. So when we implement sustainable land management, we can interrupt this change and reduce both soil erosion and flood impact. Okay, with that, I would like to conclude with this important message for us to think and to remember lah. Understanding soil erosion is not only about protecting our soil resource. It is also about protecting our community, reducing flood risk, and supporting sustainable environmental management for future generations. And lastly, thank you very much for your attention. I will be happy to answer any question. Okay, thank you.
Okay, thank you, Amirah, for the wonderful presentation. Indeed, I've heard about Kota Belud. I have myself been to Kota Belud. The
Oh, yeah,
number one, yeah, the number one. In I mean, memories that I bring back from Kota Belud is the beautiful rivers and also
Yeah.
the Kelah Sanctuary.
Yeah. Correct, Doctor. Kota
Exactly.
Belud is popular with paddy field and the view of Gunung Kinabalu lah. So
Mm.
from this place we can see the beautifully of the Mount Kinabalu Mount.
Okay, so I believe that students they probably have been to Sabah, but for those who haven't been to Sabah, just don't go straight to the mountains because below the mountains, Kota Belud is one of the wonderful places that you can go. Apart from Kundasang, I know you all been
Yeah,
to Kundasang, but let's not forget Kota Belud, the Kelah Sanctuary. Guys, you should go there. Okay, now let's start with the Kelah Sanctuary because if you don't have a nice river, the Kelah will not survive, isn't it? So
yeah,
there comes erosion and the issue. Now, let me let me be clear. Actually, I wanted the students to start with the Q&A, but perhaps I will set the I'll set the scene and let them ask question later on. Maybe that's easier for them.
yeah.
Okay. So that is the first part. Now the second part is that I noticed that in the models that you use to predict erosion. Now
Yeah.
I could say that model is very different than the one that I'm have in my course content.
Oh,
Okay. Now, I have a question for my own student. I have a question for my own student. Okay, student, listen carefully because this is very important. If you answer correctly, that will decide whether you will get a pass for your coming test or not. Okay, my first question. Have I ever teach you the Russell model? RUSLE model? Yes or no? Anyone can answer? I hope somebody answer. Switch on your microphone to answer yes or no. Did I teach Russell to you before? Come on, guys. I'm sure you can do it. I'm the one who give you the marks. Or if Amirah asks you, you don't reply a question, nothing happened to you. But remember, I give you the marks, yeah. So you better answer yes or no. Okay lah, I won't penalize you. You just answer yes or no. Anyone? Pernah tak saya mengajar model RUSLE, Russell? I need a response. Okay, so okay, now, I haven't get a response, so that could be two things. Number one, you don't know, and number two, you're not listening. Okay, Amira, I
yeah,
think
Doctor.
um, I think I also have to admit the course, the content of my course currently that I'm teaching is exactly with the one that I taught you before, like
Okay.
8 years ago.
Yeah,
I teach you USLE,
yeah.
not Russell, not Russell.
Okay. Okay. Yes. As USLE is the best. No, the we currently we for this modeling. This is called empirical. We have mathematical. For the soil erosion modeling, basically we have three kinds. Three types of modeling. No, three types of modeling. Basically, three categories lah. First is empirical, mathematic, and I forgot lah doctor the one. But for the Russell, and muscle, it's categorized into the empirical one. Okay, and I believe the Russell have been taught by Dr. Young in the previous class. Okay, but the enhance of this modeling have been uh, have been enhanced, I mean not enhanced lah doktor, ditambah baik. Okay, ditambah baik kepada Russell and juga muscle. So every three of these model, they have their perubahan-perubahan. That is the research, right? Every modeling we will be improve, top up where the leg one. So the current for the from the mother modeling asal, now we have been changed to muscle. Okay, right now.
Exactly. So I haven't actually taught the students the improved version of those
Yeah.
model, which is why I invited you to give a brief introduction of what is going on. So students, listen carefully. We no longer use USLE. We'll use Russell or muscle as Amirah had mentioned earlier. Now I know what to give the question in the coming test because they're not answer kan. So now I know what to give them. Oh, maybe I add one more question. You see, I mean, this is the reason why we give tests, right, Amira? So that
Yeah.
we make sure they know what is the latest model we are
Yeah.
using for soil erosion. Okay. So don't say that I didn't tell you, student. Listen carefully. Okay. So point number one. That's what I want to like tell the student. We have a latest model. I didn't teach you yet in the model, which is why Amira here is telling you. We have a latest model. Okay, so now I'm moving on to check if students have questions because someone is switching on the microphone. So maybe let someone have a question. Anyone have question to Amira? Ask lah anything. Tanya lah.
If not regarding on the just I told you just now, it's okay lah. If okay in Malay, jika mau tanya sebab saya dulu student Dr. Yong, student dekat program ni, and I have faced with what you have faced today lah. So if you want to ask regarding journey, postgrad journey, so it's okay, just ask anything. No shy lah. Can we sharing each other the memories, I mean the apa doktor, sharing pengalaman, pengalaman. Saya mungkin doktor malu ni doktor, malu tanya-tanya ni doktor.
Right. Until you offer them like discount ke when you come to Sabah ke. Never mind, never mind. We're not selling anything, so no discount.
Yeah.
Anyway, we can give you a lot of things for free, like knowledge. That is free right now. Anyway, I think I'll ask the next question lah, since they are too shy to ask you. Now, the next question is that when I look at the last three slides, when you look at the slide number 14. Can you go and show us the slide number 14? I thought slide number 14, they are particularly more interesting. Okay, so when you look at this map and they show us the soil loss as estimated by Russell model, is that correct?
Yeah.
Okay.
Yeah, correct. Doktor.
So those are the colored version that shows if it's red, then soil loss is very serious in that
Yeah,
area.
very severe lah doktor.
Okay, now I'm just curious, is that tied up to any reasons? Perhaps we would like to blame human activities, but is the case? Are there any other natural causes that cause this severe soil loss?
Okay, like what I just mentioned now, because particularly for the red one, it's happened at the high slope doctor, but there are some this is happened because maybe the area is being land clearing, more like that, not very the huge one, not, but we can see the little bit of pokok-pokok around that area, and besides it's situated at the high elevation, I mean at the slope, so that's why the erosion is become more severe in this area.
Yeah, I also like have some research myself, but not in Kota Belud, but more in Ranau.
Yeah,
And
right now is the most severe one, because many my click do in that area.
Yeah, and it is said that in those area they have particularly high rainfall
Yeah,
compared to the place. But of course, like you said, is due to the slope,
yeah,
which is correct. Now, while in Kota Balut and also in Ranau, they face different problem due to different activities, and the impact also is quite different. If I can share with you what's going on here in Semenanjung, particularly in Shah Alam, I'm sure you remember back in the days where you are still student here, there are many floods in Shah Alam. Do you
yeah,
remember?
yeah, correct, Doctor.
Okay, so during that time is exactly due to sedimentation of Sungai Damansara, if not mistaken, that the name of that river that causes severe flood in section 13. But these
Taman
days, I
Muda,
think,
Doctor.
yeah, these few days, I mean, these few years, section 25, Taman Sri Muda was
Ah,
uh, the, the poster lah. Last time it was section 13, but still is. But the most severe is always Taman Sri Muda, section 25. And just to share with you, last time, if not mistaken, Section 25 was the floodplains of Shah Alam. And they were not supposed to build houses over there, but still they built a housing area there. Um, so back to what you've explained earlier, it's due to land management. As you can see, Shah Alam is highly populated, whereas in Kota Belud is not. So what do you think is happening in Kota Belud that pushes the erosion to become more severe?
just like what I mentioned before, the earthquake 2015. Okay,
Hmm.
after the earthquake before the earthquake, the flood is not frequently happen. That it has its time to be happen, maybe in 10 year, in 5 year. But after the earthquake happened, the flooding become frequently to be happen. I think every year we face the flood. And Kota Blut, Beaufort, Kota Merudu, and another parts of Sabah is can be categorized as a hotspot for the flood. So what push the uh, push the flood? It's because the earthquake. Because the earthquake it changed the morphology of the sungai, alur sungai.
Mhm.
So when earthquake happened, it produced the sediment from the gunung, right? So this sediment from the hulu turun ke hilir, then it deposited in the river at Kota Blut lah. So the river from the dalam one become cetek but lebar. Kenapa? Why it's become lebar? Because the erosion happened at tebing-tebing sungai. Then it beside from the sediment from the Mount Kota from the earthquake. It also affects the erosion from the tebing. Then that's why the uh, not a main factor, but it's one the factor that accelerate the flood in Kota Blut lah, like that.
Okay, so
So,
yeah, yeah. Sir, please continue.
okay, alright. So, uh, after the earthquake, the flood uh, from maybe before this 10 years or 5 years become every year. Every year we face the flood. And from the river, what I told you about the morphology, because the sungai before this dipenuhi with batu-batu, right? Sungai basically with the river, the batu-batu at the sungai. But after the earthquake, the sungai dipenuhi dengan sedimen pepasir that come from the earthquake. That's why lah project to counter that in Kota Blut, they have pengurikan sungai. So the water flow will be nice from the hilir to the laut. Like that. Lautan Cina, Laut Cina Selatan.
Okay. So I remember that you say there are erosion happening at the banks of the river. Uh,
Yeah.
but if not mistaken, I remember when earthquake happens during my study time in Australia, they were having problems of liquefaction. I'm not sure if you're aware with liquefaction.
Oh,
Are you
didn't.
aware with that?
Not very familiar, Doctor.
Okay, this is just what I thought because anywhere where there is a severe earthquake happens, liquefaction happens after that, in which the muddy water will rise from the
Oh,
earth to the surface.
oh, debris, Doctor.
I'm not sure if that happens in Sabah, but I have seen researchers from UMS have shown that there are some puddles of mud, geological puddles of mud that they rise from the earth, and they bring all those mud that were used as cosmetic purpose, and they swim inside the mud.
Oh, yeah.
I'm not. Yeah, that is actually another case. But liquefaction happens after the earthquake. It's just I haven't seen any report coming from after the Sabah earthquake. But
Yeah.
maybe it's true that, but like you said, after earthquake there are some instability in the slope, and then there are like landslide, and then the transport of sediment from uphills to downhill that makes the flooding more severe.
Yeah.
Yeah. So it's a combination of many factors, not just one, right?
Mm.
Okay. I think I have been questioning so many. I give the student last chance. Last chance, students. Are you sure you don't want to ask question? Because if I ask the last question, then I'll tutup, yeah? I'll close, yeah? One more question from you. If you want, ask lah, anything. Still no. Okay. I think I will ask one last question and I close lah. Amirah, do you know that all these students here, right here, if they're lucky lah, they are going to inherit houses from their parents. You know where I'm going right now, right? Okay. I know young people, they still haven't earned money and they haven't buy house. Okay, house. Buying house in Shah Alam is like beli lottery. It's either you win big or you lose bad. Why? Because you know, inshallah, if you buy the wrong house and after that it floods, then habis lah.
Yeah.
As if like you don't have a house. And even worse, kan, you cannot stay inside the house and bulan-bulan you have to bayar ansuran. Okay. So student, today's lesson is not just when we sit for exam, you know. Today's lesson is for you, for your future. When you want to buy a house, you also have to remember what we learned today. Okay. Anyway, I still haven't asked a question. Amirah, what happened to the property price in Kota Belud right now? With the concern of what we are talking about here today, the erosion, the
Yeah.
flood. Uh,
If the house in the erosion hotspot or the flood hotspot, maybe the house will be top down lah, tidak akan dibeli ataupun many people will change their berpindah tempat to the another place
mm,
which have the more stable environment condition. That's why we need to, before anything, we need to identify is our place is safe from this environmental issue or not. Just like earthquake lah, because earthquake before this, doctor, we not never happened, right? Before 2015, the earthquake never happened in Malaysia. But after that 2015, uh, we for myself, we have faced several kind of earthquake lah, like that. So that's why we must memerhati sebagai pelajar environment, memahami dan memerhati what's in our sekeliling, like that.
exactly. what I'm trying to find out is that if the property price have changed in some way, because I'm sure that is beyond our expertise. That will be the expertise of economists to investigate what happened after the earthquake and what happens to the flood, because it have cascading effect. It has effect to the well-being of the community. Speaking of which, in Shah Alam, what happened in Shah Alam actually have a longer story, not just the flooding and the loss of property. Because why? Most of the property that is lost are those that are not very rich.
Mm.
Yeah. So the poor becomes poorer because they can only afford non-premium lands or properties that are sold because they have problem. And those problem, one of which is they are prone to flooding. So if that is what they can afford and they pay for it, they become even poorer. Yeah,
Yeah,
because so
because
so the yeah.
if flood happen, the car become damaged, the perabot-perabot semua dah tu,
Mm,
itu jalan dah
exactly.
tu.
Yeah, exactly. So this is why we are learning soil erosion today. We need to know how to judge before we make a big decision, such as buying a property and where do you want to stay. And okay, I think I've asked all the questions and we already passed one. So I think I'll just share one information with you, Amira.
Betul.
Immediately after the major Shah Alam flood in, if not mistaken, 2022 or 2024, there is one map released unofficially by someone that shows the new shoreline, or the areas that are prone to flooding immediately after that due to climate change. See, we haven't touched about climate change, right? Because it is estimated that in Malaysia, having high rainfall, we are estimated to have a very severe climate. Either it becomes very dry, and suddenly during wet season, it becomes very wet.
Yeah.
Yeah, many places will become flooded. Students, once again, if you haven't buy property, go see that unofficial post. Even though it's unofficial, I suggest you to have a look. Next time when you want to buy house, don't say that we did not learn this. Yeah, we learned it today. You buy house, you better buy a house that doesn't make you even poorer. So I think that is all what I want to say. The students are all here, just not sure how much they get the information, but there's one way to find out, kan, Amira?
Yeah,
I add one more question in the coming test lah, then I will know, kan? Okay, just a possibility, not confirmed, kan? Okay.
yeah.
Anyway, so that marks the end of our invited lecture. So once again, thank you, Amira,
Thank
for
you, Doctor.
sharing your time and also your expertise talking about landslide, flood mitigation, and whatever information. I hope that I can invite you one more time, hopefully after you got your PhD soon.
Okay.
It's
Yeah,
actually a
Doctor.
wish for you. Yeah, I wish you all the best
Yeah,
for
Doctor.
in your PhD candidature. Hopefully you finish your PhD and we collaborate.
All right, Doctor. I think Doctor currently can, Doctor, from paper, Doctor.
Yeah, of course. Anytime, yeah. Although soil erosion is very new to me, I that's why I said in this topic you're more expert than me. Yeah.
All right. Thank you.
Okay, so with that, I once again thank you, Amira, and
Thank you, Doctor.
students. Remember, yeah, the take-home message. There are a lot of messages that you can use later on, either in your coming examination or in your future life. Okay, so with that, that's all for today, Amira. Hope to see you soon.
All right. Thank you,
Okay,
Doctor. Thank you for
thank
this opportunity,
you.
Doctor. See you again. Okay.
Okay, see you
Bye, Doctor.
again. Bye.
Bye.